In this video, what I would like to do is introduce our final unit for the 3U course, and that happens to be the gas laws and gas law chemistry. We have moved away from the acid-base section and solutions in general, and our final stop involves looking at gases and how they behave, and even to a certain extent how they react. I'm going to do a quick little demo here which involves a reaction in the gas phase actually. Let's take a look at solids first. Well, this is my handy dandy Lee Valley coffee cup made of stainless steel, and of course it tends to have a definite shape and definite volume because the particles in this coffee cup are very close together and highly ordered. So this is true for solids. It can be expanded a little bit when you heat it, but that expansion is quite minor in nature. On the other hand, we know that liquids from the last unit have a definite volume, but the shape can change. As you can see, as I swirl this, it flows. The particles in this liquid, for the most part, are less ordered than they are in the solid, but they are further apart as well. So that's the difference between liquids and solids. We're going to leave those for now. The third one, of course, involves gases. And I went into my shop and I found a propane torch. This is a bottle, a small bottle of propane, C3H8. It's an organic chemical. Propane is used a lot in welding. It's used in torches if you want to torch off a piece of steel. Many people have it in their shops. It's very useful. Highly flammable, got to be careful. And of course we have a regulator here with a little valve. Now, this propane is under pressure in this container. Don't throw it in a campfire, that would be a bad thing. And so when we open up this valve, you might even hear it come out. This gas has an indefinite shape and an indefinite volume. When it's released, it just goes up into the atmosphere and mixes with whatever's up there. Also, this gas can be combusted. So what I'm going to do is actually turn it on and show you the reaction with the oxygen in the air. You may remember that carbon dioxide and water are both products of complete combustions. So this is just a simple combustion of propane. Now, don't do this at home. I've got a well-ventilated area here. You don't do this at home. This is something that you might use outside. So here we go. Let me just light up my propane. And there you go. So you can see it burns with a very blue flame, and the reason why that propane burns is that it is able to propel out and mix with the oxygen to make the CO2 and water. So we will talk a little bit about the reactions that involve gases later on in the unit. Okay, let's just quickly review what I've talked about. Well, like I just said, solids have definite shapes and definite volumes. Liquids, yes, they can be poured. They have an indefinite shape, but their volume is quite definite. That means it doesn't change easily. On the other hand, gases are really cool because we can change their volumes and their shapes very easily, and we can also carry out reactions with gases. The hard thing about gases is it's really hard to contain them in the lab. So when we carry out chemistry with gases, it's a bit of a challenge to measure volumes and such. Now, what have we got here? Well, when I heated up that propane, we know that kinetic energy increases, and we'll talk a little bit about that. Molecules have certain types of motions that they can undergo, and there are three main types of motion. The first is translational motion. So this involves molecules moving around randomly. Now, I'm not moving so randomly, but if we were all in the lab and we blindfolded you with the desks apart, you could just kind of play bumper cars and hit each other randomly. Might be kind of fun, although we're not allowed to socially distance, physically touch each other right now, so that would be an impossible lab to conduct, I guess, wouldn't it? However, translational motion, movement in straight lines. Rotational motion, of course, molecules on the molecular level are rotating, okay? So they can spin around in many ways, and they rotate while they're translating. So you could imagine that these molecules are always rotating and always moving. Finally, the last kind of motion that we have in all particles, more so in gases, would be the vibrational energy or motion. Well, vibrational energy just means that things vibrate and shake. So finally, don't know if I can pull this off, but molecules can vibrate, rotate, and translate at the same time. So they're shaking, they're rotating, and they're moving in straight lines. That is my best attempt at showing those three kinds of motion. So at the end of the day, temperature is simply the average kinetic energy of the particles in a substance. As we heat things up, they gain more kinetic energy. As we cool things down, they lose kinetic energy. And that, my friends, is a proportionality sign, the Greek letter alpha. We'll talk about it quite a bit in this unit. Kinetic energy is proportional to temperature. We'll talk about temperature. We're familiar with degrees Celsius. We don't use Fahrenheit here in Canada, but I will introduce another temperature scale, very important scale, called the Kelvin temperature scale. And that's the one that we will use for the most part in this unit. That's a good introduction. Stay tuned for further lessons on gas laws.